guessing the intent of this problem was for you to set up exponential regression on your graphing calculator. That's what we mean by an exponential model. Rather than showing you how to do this on a graphing calculator, I'm going to share my screen and go to Desmos. And here I've entered the data as a table on Desmos, where x sub 1, y sub 1 represent the data that was given for the length of the shell for x sub 1, and y sub 1 was the price of the shell. And then once I've set up that table, I use exponential regression, which is this tilde is what we mean by setting up regression. You can do linear regression, logarithmic regression. So y sub 1 is similar to a b to the x sub 1, and that gives you a graph over here. If I hide this functions graph, there is the model, and it gives you the values of a and b. And there's the graph of f of x equals a b to the x. By putting f of 40, I can determine what the price should be if you discover a shell with the length of 40. And then I added a column to the table for f of x sub 1, and you can see how close y sub 1 is to f of x sub 1. For the most part, we're pretty close in all respects. So I'm going to stop sharing. Come back to here. What is the length of the shell selling for $9? I don't think I answered that question. So f of x equals ab to the x. We have values for a and b. I'm not going to substitute those in right here, but we want to find out what x is when f of x is equal to 9. So we'd have to solve this equation right here, where we had the a and b values that appeared on Desmos. So we'd go something like this. 9 over a equals b to the x. We'd take the natural log of both sides. This is the log of 9 over whatever that a value was equals x natural log of b. So x would equal log of 9 over a divided by the natural log of b, ln of b. So I'll leave that to you to substitute in the values that were provided for a and b on